If you mean null, write it. If you don't mean it, don't write it. Okay, anything else?
I have a kind of detailed question because it arose during Piscine as well. The way we declare strings,
Yeah.
the norm way, is it true that the strings are then read-only?
Yeah, that's true.
So how
because
is there a
this was-
workaround?
Yes, strdup. Just doing strdup of a string will give you a copy of it. And then you can modify that copy, but in the end you have to free it again. And this is exactly the issue that I was aiming towards in the end, is you have pointers going somewhere, but sometimes the data is owned by somebody else. So the person who wrote the program created the string, so it might be wise to not modify it if some other piece of code also relied on the same string. So for example, you have the string hello that you write in your code. So you have the string hello, and you say, I have my str, which is hello, and you run this code again and again and again. What happens if you modify this h into maybe a big L? Then, well, you have modified the string now, so when the code runs over this again, the string will still be the same, because all of these references go to the exact same string. This was exactly what I meant when I talked about what if we have a copy of Berlin, or do we have the same thing? If we modify the original thing, then every copy, every pointer pointing towards it, will also see this change. So when you need something that you want to modify, do an strdup, which will just create a new copy of it, just copy every character over, and then you can modify it however you want. The only thing is, the system doesn't know when you don't need it anymore, so you need to tell it, okay, I'm done with it, which is why you use free. Free is essentially the equivalent of going to the receptionist and giving back the key that you got. malloc is going there, getting a new room. This is what malloc does. You don't know the address, but you get the pointer, and the pointer knows the address. And once you've used your room, once you're done with it, you need to give the key back. So this person is actually malloc and free. Basically, that's the best analogy to this. And also from my side, teaching this is quite a hard thing to do, because everything is connected, and you might have already experienced that from within the Piscine. There's no way to isolate things. There's not, like, when you look at one thing, you Google what's a pointer, and then it tells you a pointer is a pointer to some kind of data, and you don't know what data is. And then you go and, how is data stored? Well, in memory. And what is memory? Well, memory, you can point into it. And then you're running into these circles of what things mean, what things are, and therefore giving a full and complete picture on this is quite hard. Once you have the first picture, once you have seen all of it, like this is also my strategy here when I'm telling you that, once you have seen the rough picture, revisiting it becomes easier, and then revisiting it again becomes easier again. So don't expect to understand everything right from the beginning, but after hearing some words and how they interconnect, you can take the next step on this. And this is basically how you go into learning big systems that are like different topics that are connected are harder to learn than if you have like things that basically build on top of each other. And therefore the best thing to do is to revisit a few things multiple times, and once you know the path, then you know basically how to do things, which is what I'm trying to do here. Okay, yeah, thanks for being here, and hopefully see you the next time, and I hope you enjoyed it too. Thank you.
Could you maybe help stacking up the chairs over there, because that would be really helpful.
Yes? Soll ich so?
Aber nicht zu verwandt, oder?
Nö, also ich